China let AI take over hospitals. What happened next shocked the world. China didn't just let AI into its hospitals, it handed AI the keys. And what happened next is something the rest of the world is only beginning to understand. Over 90% of China's top-tier hospitals have already deployed AI-assisted medical systems. That's not a forecast. That's not a pilot program. That happened between 2023 and 2024. To put that in perspective, the entire United States has around 6,000 hospitals. China did what would be the equivalent of rewiring nearly every single one of them in under 2 years. You heard that right. The largest hospital AI rollout in human history, and most people outside of China have no idea it's already done. What you're about to hear isn't a preview of the future. It's a report from the present, and it starts with a machine that sees cancer before your doctor even picks up your chart. The machine that sees what doctors miss. Picture this. You walk into a hospital somewhere in China. You get a chest scan. Before the radiologist has even pulled up your file, an AI has already read every single image, flagging a 4mm nodule in your lower left lung. Something a tired doctor, on their 14th hour of a shift, might have missed entirely. And in China, that kind of fatigue isn't the exception. It's the daily reality. Here is a number that should stop you cold. China has roughly 80,000 radiologists to cover a population of 1.4 billion people. That works out to approximately 1 radiologist for every 70,000 people. You heard that right, 1 radiologist for every 70,000 people. In the United States, the ratio is closer to 1 per 7,000. China's radiologists are outnumbered 10 to 1. And yet the demand for imaging is growing at 30% per year, while the radiologist workforce is growing at just 4%. The math doesn't work. It has never worked. And for decades, that gap was filled by exhausted doctors, making high-stakes decisions under impossible pressure, and sometimes getting them wrong. China's average misdiagnosis rate sits at 30% nationwide. In rural hospitals, it climbs as high as 40%. Cancers missed. Heart attacks misread. Lives altered by a scan that was reviewed too quickly, by someone who had already read 300 scans that day. This was the crisis AI walked into. But this was just the beginning of how deep the problem ran. Because it wasn't just the number of doctors that was the problem. It was what they were being asked to do. A single CT scan generates hundreds of image slices. One patient, hundreds of images. Multiplied across an entire hospital's daily load, you're asking human beings to do something they were never built to sustain. Perfect attention, at scale, day after day. A radiologist has roughly 3 to 4 seconds per image in a busy workflow. 3 to 4 seconds to decide whether what they're looking at is normal or the beginning of someone's cancer. Then came AI, and the numbers shifted in a way nobody expected. Companies like InfraVision out of Beijing began deploying deep learning systems trained on millions of real patient scans pulled directly from Chinese hospitals. Their AI doesn't get tired. It doesn't lose focus on scan 400. In head-to-head testing against human radiologists, InfraVision's system outperformed the doctors in every single nodule category tested, detecting more accurately, more consistently, and far faster. Today, InfraVision's platform is running live in over 300 hospitals, processing more than 33,000 diagnoses every single day. One AI, 300 hospitals. 33,000 reads a day. That is not a research project. That is an operating medical system. And it's not just lung cancer. DeepSeek's medical AI, embedded in the internal networks of over 260 hospitals across 93% of China's provinces, is processing 3,000 pathological slides per day at Ruijin Hospital alone. 3,000 slides at a single hospital per day. The speed at which this system analyzes tissue samples would take a team of human pathologists days or weeks to match. At Zhongshan Hospital in Shanghai, an AI-powered chest scanning tool built on a foundation model called UAI Nexus detects up to 73 types of abnormalities in a single CT scan automatically and highlights the suspicious areas before a human physician ever looks at the screen. The workflow has flipped entirely. Doctors are no longer writing reports from scratch. They are verifying what the AI has already found. And then, they applied this same logic to the heart, which is where things got truly extraordinary. CardioMind, China's first cardiovascular specialty AI, launched at Shanghai's Zhongshan Hospital. The hospital's cardiology department handles 820,000 outpatient visits a year across just 136 physicians. That is 6,000 patients per doctor per year, before accounting for inpatient care, procedures, or sleep. CardioMind doesn't just read ECGs. It processes electrocardiograms, ultrasound images, and lab results simultaneously, cross-referencing them against each other the way a senior specialist would, but in a fraction of the time. The hospital's director of cardiology put it plainly: they aren't just feeding it data, they are teaching it to think like a top expert. The payoff of all of this lands hardest when you think about what early detection actually means. Lung cancer caught at stage 1 has a survival rate of over 90%. Caught at stage 4, it drops to under 10. The difference between those two numbers is often nothing more than timing. A scan read quickly, a nodule noticed, a flag raised before symptoms appear. China has one of the highest lung cancer rates in the world, claiming over 600,000 lives every year. AI isn't just speeding up the paperwork. It is catching cancers that would otherwise have been missed in a country where missing them was, for a long time, almost structurally guaranteed. And if what AI can do in the radiology suite already shook you, just wait until you hear what it is doing in the operating room. The robot challenging the king of surgery. For over 2 decades, there has been one name that has ruled the operating room. One machine so dominant, so deeply embedded in hospitals across the United States, Europe, and Asia, that surgeons have trained entire careers around it. That machine is the Vinci surgical robot, and for most of the world, it has been the only serious option for robotic-assisted surgery. But in China, that is no longer true. The Vinci costs between $1.5 million and $2.5 million per unit to acquire. Then, there are the ongoing expenses, an annual service contract of up to $190,000, plus instrument and accessory costs that can run anywhere from $600 to $3,500 per individual procedure. For a hospital in Shanghai or Beijing with deep pockets and government backing, that is expensive but manageable. For hospitals across the rest of China, the ones serving hundreds of millions of people in mid-tier cities, rural provinces, smaller communities, that price tag has meant one thing: no robot at all. As of the end of 2023, only around 360 Da Vinci systems had been installed across all of China. In the United States, there were over 5,000. The world's most populated country had been locked out of the robotic surgery revolution, not because the technology didn't exist, but because no one could afford the ticket to get in. But this was just the beginning of China's answer to that problem. The robot that replaced the surgeon, and the one that never needed one. For over 2 decades, one machine ruled the operating room. The Da Vinci surgical robot, built by Intuitive Surgical in California, became the global gold standard for robotic-assisted surgery. Hospitals paid between $1.5 million and $2.5 million per unit just to acquire it, then up to $190,000 a year in service fees on top of that. For hospitals in the US or Western Europe, expensive but manageable. For the thousands of hospitals serving hundreds of millions of patients across China's mid-tier cities and rural provinces, entirely out of reach. By the end of 2023, China had roughly 360 Da Vinci systems for 1.4 billion people. The United States had over 5,000 for 330 million. The world's most populated country had been systematically locked out of the robotic surgery era, not by capability, but by price. China's answer was Toumai. Developed by Shanghai Microport Medbot, the Toumai endoscopic surgical robot arrived with a price tag of between $800,000 and $1.5 million, nearly half the cost of a Da Vinci, and came with something Da Vinci couldn't offer in China: partial medical insurance reimbursement in multiple provinces. It performs minimally invasive procedures across urology, gynecology, thoracic surgery, and gastrointestinal cases. It filters surgical tremor. It gives the surgeon a 3-dimensional high-definition view inside the body. And when researchers ran randomized controlled trials comparing it head-to-head against the Da Vinci in prostate cancer surgery and partial kidney removal, they found no statistically significant differences in outcomes, complication rates, blood loss, or patient recovery. 0. For the patient lying on the table, the results were the same, at half the price. In lung cancer surgery, lobectomy comparisons showed matched perioperative outcomes between the two systems. The medical case for paying a premium for Da Vinci is eroding fast. And it isn't just Toumai. China now has an entire fleet of domestically produced surgical robots. The Edge MP1000, the Kangduo SR1000, the Micro Hand S, all approved, all deploying, all driving a price war against a system that has held a monopoly for 20+ years. In the first half of 2025, Chinese endoscopic surgical robots generated more overseas orders than Da Vinci installed new systems in China during the same period. China isn't just buying surgical robots anymore. It's building them, deploying them at scale, and now exporting them globally. But the robot with a surgeon at the controls was only the first part of China's operating room revolution, because something else was happening, something that removed the surgeon from the equation entirely. This is the part where you sit up. In Xi'an, Shaanxi province, a woman sat in a dental chair under local anesthesia. Medical staff were present in the room, but none of them touched her. A robot, developed jointly by the 4th Military Medical University and Beihang University, had already analyzed her CT scans, planned the implant positions, calculated the precise drilling angle and depth, and was now executing the procedure on its own. Over the course of 1 hour, the robot fitted 2 artificial teeth, built using 3D printing technology, into her jaw. The margin of error was between 0.2 and 0.3 millimeters. That meets the required clinical standard for that class of surgery. The staff in the room were observers, not operators. Think about what that means. You trust a surgeon because they spent a decade training, because their hands have done this hundreds of times, because they can feel resistance in bone, adjust in real time, make judgment calls in the half-second before something goes wrong. The question China forced the world to sit with is this: what if a machine is more precise than those hands, and what if the data proves it? The answer, increasingly, is yes. Autonomous dental implant robots in China operate within tolerances that outperform freehand human placement in multiple clinical studies. The system reads the patient's movements during the procedure and adjusts continuously. It doesn't get tired on the 14th implant. It doesn't have a bad day. And China has 400 million people who need new teeth, with nowhere near enough qualified dentists to provide them, a shortage that gave this technology both its urgency and its testing ground. Then came orthopedics. China's domestically developed Thai robot orthopedic system has been deployed across tertiary hospitals nationwide, executing spinal fixation procedures with AI-guided screw placement that achieves precision levels beyond what freehand surgery can consistently deliver. AI-driven planning tools analyze CT and MRI data, calculate optimal screw trajectories, predict how hardware will interact with bone density and spinal stability, and then guide or execute the placement accordingly. In complex spinal deformity surgeries, AI-driven planning has already demonstrated an 18% reduction in post-operative complication rates. That isn't theoretical. That is outcome data from real patients. The West has largely kept humans in the loop. Surgeons remain in control, robots assist. China's regulatory environment, combined with the sheer patient volume that creates both the pressure and the training data, has allowed it to push further, faster. Semi-autonomous systems are already running. Fully autonomous functions are expanding. The line between robot-assisted surgery and robot-performed surgery is getting thinner by the year, and in China, it is already thinner than anywhere else on Earth. And if a machine operating your spine without a surgeon steering it in real time already pushed the limits of what you thought was possible, just wait until you hear about the surgeon who was 3,800 miles away. Enter Toumai. Developed by Shanghai Microport Medbot, the Toumai endoscopic surgical robot is China's most advanced domestically produced surgical system, and it is coming directly for Da Vinci's crown. It operates across urology, gynecology, thoracic surgery, and gastrointestinal procedures, offering the same foundational capabilities that made Da Vinci the global standard: three-dimensional high-definition visualization, tremor filtration, and multi-axis instrument articulation that lets a surgeon work inside the human body with a precision that human hands alone cannot achieve. But Toumai comes in at between $800,000 and $1.5 million per unit. And critically in China, it is eligible for partial medical insurance reimbursement in multiple provinces, while the Vinci is not. That single distinction changes the entire calculation for which robot a hospital chooses. Then came the clinical data, and for Vinci, that's when things got uncomfortable. Randomized controlled trials comparing Toumai directly against the Vinci in prostate cancer surgery and partial kidney removal found no statistically significant differences in surgical outcomes, complication rates, blood loss, positive surgical margin rates, or patient recovery metrics. Zero. The procedures took slightly longer with Toumai in some cases, but the results for the patients were, by every meaningful clinical measure, the same. That data matters enormously because it removes the last serious argument for paying $2.5 million for a Vinci when a Toumai delivers comparable outcomes at nearly half the price. In lung cancer surgery, a lobectomy comparison study found perioperative outcomes were essentially matched between the two systems. The surgical establishment's most trusted justification, that you get what you pay for, is starting to erode. And it isn't just one robot. The Chinese surgical robotics market has exploded. The Edge MP 1000, the Kangduo SR 1000, the Microhand S all have received regulatory approval. All are deploying across Chinese hospitals. And all are driving a price war against a system that has held a monopoly for 2 decades. By December 2024, over 400 robotic surgical platforms had been installed across China, with domestic systems claiming a growing share of those installations with every passing quarter. In the first half of 2025 alone, Chinese endoscopic surgical robots generated more overseas orders than Vinci installed new systems in China during the same period. You heard that right. Chinese surgical robots are now outselling Vinci's own growth in China. But the most striking thing about Toumai isn't its price. It's where it went next. Toumai holds a distinction no other surgical robot in the world has yet matched. It is the first teleoperated surgical robotic system officially authorized for commercial clinical use, meaning it doesn't just operate inside a hospital. It operates from thousands of miles away, over a live network, on a patient it cannot physically reach. The system has completed 5G-assisted surgeries across China, including a urological procedure where the surgeon sat at a console in one city while the patient lay on a table in another, connected only by a 5th-generation wireless signal traveling at millisecond latency. That capability, which we will come back to in a later chapter, is not a feature Vinci can match in any current configuration. The world's most dominant surgical robot has a genuine challenger for the first time. And that challenger is building its own empire, one hospital at a time, in a country with over 1 billion patients who have been waiting for a robot they could actually afford. But the robot with a surgeon's hands was only the second most unsettling thing China deployed in the operating room. Because something else was also moving through Chinese hospitals, something that didn't need a surgeon at the console at all. The surgeon 3,000 miles away, and the machine that learned to walk you home. A surgeon sits down at a console in Sanya City, in southern China. His patient is in Beijing, nearly 3,000 miles away. The year is 2019. The procedure is brain surgery, and the network connecting them is 5G. He guides the implantation of a deep brain stimulation device into a patient with Parkinson's disease, with a lag time so short that when he's asked about it afterward, he says something that should stop you cold. He says he barely felt the patient was 3,000 kilometers away. That was the first. But China didn't stop there. By 2023, using the Toumai robot and a customized 5G network from China Telecom, surgeons in Hangzhou completed the world's first 5G ultra-remote liver resection on a patient in Xinjiang, a communication distance exceeding 3,100 miles. Then came the satellite leap. In 2025, Chinese surgeons operated on 2 liver patients in Beijing from a console connected through the APSTAR 6D satellite, orbiting 22,300 miles above Earth. Surgical command data traveled a round-trip distance of nearly 93,000 miles per operation. Both patients were discharged within 24 hours, with minimal blood loss and no major complications. The lead surgeon put it simply, this expands the reach of surgical robots from 3,000 miles to potentially 93,000 miles. Think about what that means for 600 million people in rural China who have never had access to a specialist surgeon. The distance between the patient and the best doctor in the country just became irrelevant. But then comes the part of China's medical revolution that hits differently, because it's not about the moment of surgery, it's about what happens after. China has 28 million stroke patients. 80% of them will carry lasting physical damage, arms that won't lift, legs that won't respond. The gap between surviving a stroke and reclaiming your life used to be filled by physical therapists, by repetition, by years of grueling work with uncertain outcomes. Fourier Intelligence, founded in Shanghai in 2015, decided to close that gap with an exoskeleton that doesn't just move your limbs, it reads your nervous system. The X2 lower limb rehabilitation exoskeleton uses sensors at the thighs, knees, and feet to detect the user's movement intentions in real time, generating force through motors at each joint to translate neural signals into actual steps. It doesn't drag you through a preset program. It listens to what your body is trying to do and helps you do it. That distinction, passive versus adaptive, is the entire difference between a machine and a collaborator. By 2019, Fourier had already placed its rehabilitation devices into hundreds of hospitals and care centers across more than 10 countries. Its X2 costs between $42,000 and $70,000, a fraction of what Western competitors charge. Exo, bionics, once considered the global benchmark, has watched its market position erode steadily. Fourier is now integrated with EEG brainwave reading equipment, allowing some patients to begin controlling the exoskeleton's movements through thought alone. China has over 28 million people who need exactly this, and a company built and priced specifically to serve them at scale. This is what China let AI do to its hospitals. Not a pilot, not a press release. AI reading your scans before your doctor opens your chart. A robot performing your dental implant without a surgeon's hands ever touching the drill. A machine matching the Da Vinci's outcomes at half the price, and now outselling it on its home turf. A surgeon operating on your brain from the other side of the country, and an exoskeleton strapped to a stroke patient's legs at $42,000 that listens to her nervous system and helps her walk again, while the Western equivalent sits in a lab at 3 times the price waiting for regulatory approval. The title of this video asked you what happened when China let AI take over its hospitals. Now you know.